Internet of Things makes our cars driverless, our homes connected, our cities smart, and factories run seamlessly. Artificial intelligence combined with IoT data is where the business value is created. Imagine yourself in the driverless world. I will teach you to pivot your career and innovate in your business using IoT, AI, and autonomous vehicles. Let's begin your journey with me today. Hello, everybody. I'm Sudha Jamthe. And today in our show, we have a guest, Professor Ahmed Banafa. Yes, the name is familiar because he's an expert in the IoT and blockchain space, and he's been at our show before talking to us about AI. Welcome, Professor. How are you?
I'm doing well. Nice to see you again, Sudha.
Thank you. So, you have a new book, I heard. Do you want to show us the book?
Absolutely. The book, the title of the book is Secure and Smart Internet of Things using Blockchain and AI. It's bringing together all the technologies that we are talking about them now, the hot trends in technology, and it's explained it in a way where it is very simple and straightforward, away from all the technical jargons. It's now on Amazon, and it's, as of this morning, it is #1 in industrial tech.
Wow. Congratulations.
Thank you.
And you also have a new course on blockchain at Stanford?
That is correct. It's actually at the continuous studies at Stanford. And the book, the class title is Blockchain Technology and Applications. It's another high-level view of the technology, which is a buzzword now. Everybody would like to hear about it and know about it. To explain it, it's really 6 weeks class, and it's on Monday from 7 to 9. It's going to start on the 28th of January of 2019.
So the class is called Blockchain Technologies?
Blockchain Technology and Applications.
Blockchain Technologies and Applications.
That's correct.
So anybody can take it, or you need to be a technologist, or you need to have hands-on experience? Who can benefit from this class?
Everybody is welcome actually to the class. The class is not a deeply technical one. You will know about the technology. You will have some demos in front of you, but you're not required to do any coding, programming, or to worry about the technical aspect of it, that you're going to do it by yourself. But you will understand it because I'm going to do everything on my side.
Fantastic. So today's topic is blockchain. So it's perfect that we got Professor Banafa, who has written a book and is getting ready to teach a course at Stanford Continuing Studies. So blockchain is one of those topics that is not just a buzz, but it seems to have a life of its own. Every day there's yet another jargon in there. So I look at blockchain purely from an IoT point of view. So I want us to get to a common starting point. Right. What is blockchain technology?
Blockchain built basically on trying to remove the centralization of the systems we have, the single point of failure, the access of the hackers, or of the of anybody who would like to get to the system through one point, and then he or she will be inside the system. It's taking this out of the picture and making sure that it's distributed, trusted, distributed, information is distributed, multiple copies of the information everywhere. So if one missing, then you have 100,000 copies, of the information. So the starting point of the blockchain is the peer-to-peer connection. No one in the middle. You save the trouble of sending the information to somebody and process it and then send it to the other party.
So give us an example of what does blockchain mean? Like we were talking earlier about, explaining that to a
right.
fifth grader.
That is correct. That was a question from one of my students, excuse me, one of the students at the University of Texas. Austin, he emailed me and he told me, I have this question. Somebody asked me, how can I explain it to a fifth grader, 11, 12 years old? I was thinking about it and I say, this is a valid question, which is, in another term, it means explain it to somebody who has no technical background. So this is how I explain it. And I use exactly the same words. The student, that fifth grader sitting in his class, or he or she sitting in that class, and if somebody tried to come in to the class, the teacher will allow that person to come and sit in the class. This is what we have right now, the centralized one point of access system or model. in the blockchain, that person cannot sit in the class unless more than half of the class will approve that person. Yeah, I would like to have this person is with us. This is just to explain it to the fifth grader. But if we take it on a bigger level here, a building with 100 employees, and there is a security guard at the door, check my credentials, approve that it's okay, and then I get in. Once and inside that building, I can do whatever I want, whether it's good or bad. With the blockchain concept, it's completely different. Over 51% of the people in the building has to approve that I can be in that building. So it looks great, but if you think about it deeply, you'll understand this is more in depth than what we think about it of just an approval. I can talk to the security guard and I can tell the security guard, he or she, listen, I have a situation, can I get in, if I forget my card, and then sometimes it will let me in. But I cannot do the same thing with 51 people there. The minute I start talking to one or two, everybody will say, what's wrong with this person? Get him out. The 51 plus are the nodes, and the nodes has a copy of my information. If they see that it's not matching whatever I told them or I show them as my credentials, they will cancel that transaction, which means they can ask me to leave. I can convince 5, but cannot convince 51, 52, or maybe 1,000 people. That's going to be very hard. And that is the strength of blockchain.
So everything is every entity is a node. So it could be supply chain, it could be a financial transaction, it could be anywhere where one central entity does not have control.
That is correct. I mean, a blockchain is designed for digital assets, which is information, data you have. You want to secure this data. So in order for you to secure this data, you have to get rid of a single point of failure or single point of control, which is the centralized. So that's out. Number 2 is, what if you lost this data? There are multiple copies of the data on the other nodes, and there are ways for verifying this through encryption and through comparing the data. I look at the picture and somebody look at the picture and say, oh, that's the correct person here. So the guarantee for you that your data will be safe and be correct will be the same data that you sent at the beginning is higher when it comes to blockchain, instead of relying on specific points to verify it.
So every time we hear about blockchain, we're always hearing about applications. So from a technology perspective, when you say it's a node, where does this node sit? So if I want to use blockchain, or somebody in your class says, I'm technical enough, but I just want to understand where is it a piece of software? Because
Right.
The general description of blockchain is always given as blockchain is a distributed ledger, as if it's some kind of database. Does it mean somebody sets it up, somebody puts it somewhere in the cloud? Does that give them control? Where is this software living, or is it something else?
Okay, the first part of your question about the node, you could be a node, I could be a node, anybody could be a node if it's a public blockchain. If it's a private one, which is built by the company, then that's why we call it permissioned and permissionless blockchain. So if it's a company, then I have to be part of the company to be a node. A node is basically a computer software that on my computer where I can enter information and then I have access to the network. And this can be done with a browser plugin, could be a local app there that could be an access for the network. So this is from one side. The application for the blockchain itself and how it can be used and where I can see it, it is treating the transmission of the data to make sure the data is correct. For example, if there is a sensor somewhere and sending the information to the Wi-Fi or to the Bluetooth or the Ethernet, that area, that sensor, we'd make sure that we are dealing with the right sensor. We are dealing with the information from the right sensor. This with the blockchain will help with that one. And then taking that information and send it to the cloud, that's another part. Blockchain will verify the identity, and I'm going to come to the word identity here because this is a keyword for the blockchain, and then goes to the application after the processing at the cloud. The application also will be verified by the blockchain. So every time you need security, you need verification, you need authentication, you will think about the blockchain. Identity management is one big field for the blockchain because it is very simple to understand it from perspective of there are multiple copies of the information you're talking about at different places. You can fool few, but you cannot fool everyone.
That's fantastic. So tell us about smart contract, because every time we say there is no central entity, one of the examples is smart contract.
Right. Smart contract. Uh, the history of smart contract came as the evolution of the blockchain, and it's actually following certain stages. Ethereum is the one who created the smart contract concept, and it's a software. I mean, blockchain is a software. You can build it with C++, Python, Java, whatever your favorite programming language. Bitcoin built with C++, and smart contracts are not difficult. I mean, there are. If you look at the structure of the program, it's very simple, straightforward. It's easy to understand. But the more important thing about it is how the smart contract itself works. I'll give you a simple example. Advertiser have a contract with the influencers, the YouTube stars, and they told them, run this ad, on your channel, and if it hits 1 million views, then we'll pay you. Now, I can program a smart contract where the smart contract will keep watching that channel. When that ad shows up and the views hitting 1 million, then the money will transfer to that person. This is just an example. We're taking the escrow account out of the picture here. Nobody will hold the money until the both parties finish this one. It's actually conditions. It has to be satisfied. Once you satisfy the conditions, you get the money. Same thing goes.
We wanted to sell a car.
Right.
And it's used car. We want to sell it to somebody, and we put it on Craigslist. Whole bunch of people show up, right? Then we say, no, we want to see you for real, and they show up. But still, when we say, okay, we're ready to sell you the car, then we don't know whether the check is going to be legitimate, or whether for them, whether we are the real owners of the car. So on both ways, we need, trustless network like blockchain. Where would I go? I mean, is there a public blockchain, or can I go use this somewhere if as a ordinary person, I want to see if I can just do this?
Well, building a platform, a blockchain platform is not difficult. If you know programming, you can do that. The key thing is that you need more nodes. So the more nodes you have,
somebody else to validate. So
correct.
It's not just the two of us.
Exactly.
So there could be. So it's not for common man for real. It's more for somebody could provide an application. One of our students could build something and say, here is a smart contract app of some kind, and have more people come in who validate who I am, who validate, go check this with the DMV and say whether the owner of the car, validate
and the bank
person has money in the bank, and
certain conditions has to be satisfied. It's a very simple if statement, if and if and if. Once you satisfy that one, then you go say, okay, do this and transfer the money. All of these things will they taking the human out of the picture. You taking any kind of fees will be included in the process. You are not holding the money until everything is done here. It is and there's some really amazing conditions for the smart contract. You can specify the geolocation of that person, like the altitude and attitude of that person. If you are standing in that area, the money will go there. And because I can find this one from your smartphone, and you can show me your the video, the pictures, match it with some information in the smart contract. So you think about it as wild as you want.
I had seen an example of this in India. I've heard about this in India, where when you apply for a passport, the policeman comes home and verifies that you're that same person.
Correct.
And then in India, they had a lot of bribery, so they've been trying to get rid of it. So they have an application where when the policeman would come and then talk to you, and then they would talk to their neighbors and say, okay, this person lives here, this is the right person. And they would just go away. Or they might not even do this and then say, hey, pay me some money and I'll just validate who you are. Then that's not okay. Mm-hmm. So because, especially it's international passports, right? And becomes your identity. So they wanted to keep this check and balance. So what they do is they actually have to show up at the house, and then they have this app from the passport office where they have to validate that they are at that location.
Correct.
And with the same person and all that stuff that they've built in as an application.
Yes.
So they could very well do this with blockchain, and then the neighbor and whoever else on the other side and whoever else in the house and all the entities involved could actually
verify that.
Something that could become a blockchain application. That's beautiful.
It's used in Europe, actually. Some of the Scandinavian countries, they use that. You don't have to go and apply for all this process and wait for this one. There is actually a blockchain application for it, and I think it's Sweden, if I'm not mistaken. I can check that. But now you are getting really in the way of thinking about, okay, how can the blockchain help us? I mean, the first thing comes to your mind is identity theft, identity management. That's just fantastic, because the verification is done by multiple parties, not just one person. And you give a good example, an excellent example about, somebody comes to your house and verify this one. It's the same example of me going to that building and bribing that security guard, or talking to that security guard, okay, I have a situation. And then everything is open to me after this one. But with the blockchain, you have to go through multiple nodes or multiple verification before you can even get, through the system.
So you mentioned something very interesting, that it removes the middlemen, so there are no fees.
Correct.
But I also hear that banks are adopting blockchain, and banks make money.
Right.
So I also hear banks are adopting blockchain, and they make money by being the middleman, right? They serve a purpose, because I would trust a bank and interacting with another bank to make sure my money moves, because it's a big deal for me, right? So I'm okay to pay that little fees.
Right.
But so where's the role of the bank if the middlemen and they are the middlemen being eliminated? What is their play? What is the role of blockchain in fintech? It's a big deal, and especially banks.
Correct. I mean, it's a very valid question and an excellent question. The banks are really they are big players in the blockchain arena. Until recently, Bank of America was the highest number of patents that filed for blockchain, until Alibaba took over in August now. Why they are in? That's a good question. The thing about it is, number one, they don't want to be left behind, because this is a big, huge move in the industry. Number two is they can have their own blockchain network where people can use it and they can charge people for that. And they're doing that because there is actually a third type of blockchain beside the public and the private, which is federated, or community blockchain, with multiple companies, including the bank, can get together and create a big blockchain network with many nodes and just ask people to use it, like what happened with Ethereum. They charge you a small fee, it's called gas. And that one adds up when you're talking about hundreds of thousands of people using the network.
So the banks get together and they have this federated blockchain?
That is correct.
Is there a standard? Is there like one federated group for all banks, or is there a global one, or again, there's many of those?
Well, Sudha, you are really, really asking the right questions. Some of the challenges for the blockchain is standardization. We have about 100, 200, 300 well-known network of blockchain. We have thousands of the platforms. I can create one tomorrow if I want. There are no standards so far. Only the big names like Ethereum and Bitcoin and the others that really they're making the standards for us. So the standardization is a problem for the blockchain. And this is very, very normal for a new emerging technology. That standardization cripple innovations. So we don't do it at the beginning. We wait until we see there is a problem, and then we say, okay, we should do this, we should not do that. So the standardization is the problem. The regulation also something that they look at it. And if you remember, we talk about the three filters or the three lenses for any new trend, which is the technology. We have the technology, we have the programming, we can create blockchain. And now we go to the second filter after this, which is the business. What's in it for me? The VCs, all the companies. The highest concentration of investment of blockchain is actually in the Silicon Valley, in the San Francisco Bay Area. And then you can go to New York after that, which is, it makes sense to me because Wall Street. And then you go to China after that one, because they're looking at this one as the future for the fintech. So that is for the business. The third one is the society in both parts, the government and the citizen. The government is the regulation. They are very careful about it. And I'll give you a very specific example about this in 2 seconds here. When you talk about blockchain for healthcare or blockchain for education, you are dealing with huge regulations. FERPA for the education and HIPAA for example, for the health industry. So they have to keep this in mind.
Perfect. So we spoke about blockchain, we spoke about smart contract. And I think I really understand the private federated and the public blockchain better than any other previous sessions that I've had. So I would like to go to my favorite topic of IoT and
Yes.
blockchain, because I have students working on that. I do cover that in my class, but as a blockchain expert, I want to hear from you. But how does this all connect together? Are there more technologies? How does this all come together?
Uh, the title of my book is Secure and Smart Internet of Things Using Blockchain and AI, Artificial Intelligence. And this is where you see the connection of the three technologies here. But they're not the only one. There is actually 4 trends that, our wave in 2019 and beyond, which is the hot trends in the technology. And I have an acronym for that one. It's called IBAC. And that one is covering all the 4 technologies. Yeah, please go ahead. Oh, perfect. Thank you. So if you look at the I for the Internet of Things, look at the B for the blockchain technology, and the A for the artificial intelligence, and C for cybersecurity. You have to think about it for a second and say they are interrelated. Internet of Things is the connection of the physical and the digital world. Okay, that's simple to understand. Think about Alexa, think about everything around you sensing and acting. And then you could talk about the blockchain to secure this kind of actions, connectivity, information. And then you talk about smart actions, which is, okay, so I enter this data, artificial intelligence will help me, processing this one and giving the right decision. And then the whole thing is revolving or living in the cybersecurity field, which is protect everything inside it: Internet of Things, blockchain, and artificial intelligence. One of the items that or the topics I talk about it when I talk about blockchain and artificial intelligence, cybersecurity, the artificial intelligence is the first line of defense for cybersecurity, and blockchain is the second line of defense of technology. And I go in deep about that one, or in depth that one in my class. I explain it in more details.
So you had you had another slide about
Yes.
how this all comes together.
Yes, and I hope you can share it with us, because that's going to make it so easy for us to understand. Perfect, excellent. Now you ask me that question, Sudha, and a lot of people ask me about it. Okay, where I can visualize the 3 technologies here. And if you look at this diagram, you're going to see that you have blockchain for the sensor to verify that the information and the sensor is the sensor you're talking to, or the sensor you expect the information from. And then you have all of this transmitted to the network and communication, Wi-Fi, Bluetooth, Ethernet, you name it, Zigbee, whatever, connection you have. And this one will be transferred to the platform, IoT platform, including the cloud, including whatever platform you have with big companies, small companies. At that area, which is the IoT platform, you will see the interaction of the 3 technologies: the blockchain to make sure that everything is secure, all the information sent to the cloud or the platform. At the same time, the analytics, the processing of the data done by the artificial intelligence. After we are done with it and have the decision, and AI will send, okay, you should do this and this, I want to send it to the right people. Somebody who has his smartphone and received that information, I want to make sure that this is the right person who received that information. And this one is done by the blockchain. And this diagram just sum up everything about the 3 technologies.
Fantastic. I actually recently had a speaker, Mrinal Wadhwa, who runs a startup. He's a co-founder, CTO of OCAM, which is a blockchain just for security.
Yes.
And they were talking about how you could have a over-the-air update, but that could have been hacked. It could not have been received by somebody else. So you can validate when I get an over-the-air update from Tesla, or I get it from any of the devices which uses AI, and I don't even have to think about it as a consumer, right?
Correct.
That it validates that it's coming from the right source. It's not just a individual encryption by the company, but it's kind of trusted overall. Similarly, there's a lot of examples in IoT about supply chain and other things. So I want to pause and ask you about IoT and blockchain. So one example you said is different layers of IoT, from the sensor to the actual transport layer, communication, cloud, and then coming back to the application. Every step of the way, there is a risk that some hacking could happen, and we can validate that. So what does IoT and blockchain bring that IoT by itself with just some encryption could not do?
It is the availability of the verification process. Again, whenever you approach a problem like this, where I send an information, I'm not sure who will receive it, I'm not sure the information will be the same information I'm sending. The same thing happened on the other side. This information coming from the trusted source or not. The blockchain principle itself, or the concept, is all about the identity, management or verification. I will make sure that I have blockchain in those critical parts of the IoT. Why? Because that's going to give me assurance that it came from the right sensor. It came from a scanner that scanned something on Tesla and then send the information back to the factory. So that's the right Tesla. That's the Tesla that at that location did that. The same thing when the factory received this one, we can verify that this is Tesla belongs to us, and it belongs to that that driver. So, and you have multiple copies now. The assurance of this one is multiple copies. And yesterday we talked about, okay, Ahmed Banafa. Okay, you know me, and few people here know who I am.
A lot of people know you.
Okay, thank you. I don't want to say that word. So what happened is, if somebody else came and said, no, it's me. No, I am Banafa. It's not. Then everybody say, listen, I know the guy. I saw the guy. I thought the voice is different. The picture is different. Everything is different. And they say, no, that's me. Okay, but if 50 people to say you are not that person. Now, that's exactly like the blockchain. The nodes will say, no, this kind of information does not match the record I have. And this is from where we get that, the ledger, the distributed ledger, because we have copies everywhere. So then you can say, you are claiming you are this person. That's not true. No, that's not going to work for me. So, and they just kick that transaction or reject that transaction or fork it out. So it will be out of the, so you have this trust, distributed trust, you have this verification process, encryptions, all of them there will give you multiple layers of confidence in the system. And this is what we are looking for. This is the basic thing that 10 years ago, blockchain, NAS Discover actually built or proposed to solve this very problem about verification.
So we've spoken about identity and security at every step, especially since IoT has many discontinuous layers, right?
Correct.
Incompatible softwares where anything could come in, right? Other than that, one example I commonly see in my classes, I have a student in my IoT business course at Stanford, continuing studies, who talks about building a cold chain system. In fact, he's building a cold chain system as his business, and come to my class to build out the business side of it. And what it does is it tracks produce or medicines or anything that is shipped using temperature sensors to make sure that it is kept at the right temperature as it should be during transport.
Correct.
And it's, like you said, it's sensors, and then it's checking some validation of the sensors, and by maybe at the gateway, and there's analytics at the edge here, and then it sends to the cloud at some point when something goes wrong, and there's an application layer to connect to the wholesaler or their customers in the process. But he also was talking about how it creates transparency of, if a product was received from a certain farm versus another farm. And so the strawberry recalls or the lettuce recall example that, we were talking about, right? So instead of just saying, okay, all lettuce is bad, we can actually track, or if the retailer, the wholesaler, and the entire supply chain had worked on a blockchain system, they can transparently say this came from this particular farm, and then all these boxes have to go, and everything else is okay.
That is correct. And you can imagine the how many lives we're going to save. You can imagine how much money companies will save. I mean, Walmart now, they demand that any vendors have to have the blockchain as part of their proposal when they are dealing with them. So this shows you big names, they realize how much money they're going to be saved by doing something like this. On Thursday, I give a presentation at Normandy in France, and that presentation
I saw that on Twitter. So you had this beam with
yes, it was the they call it it was really a fantastic way. I was controlling the robot from San Jose, when it's getting into the stage, and I moved around, and if somebody asked me a question, so I can look at that person when he or she asks a question. So it was really a good experience. Now, most of the people attended that presentation. It's about 100. They are executive in pharma industry, so they're worried about the medication. They're worried about the medicine when it transports from one area to another area. Somebody will take it or will fake it, and then and that's gonna create tremendous damage to to everybody when you have a medicine that's not supposed to be
Yeah.
the right medicine for you. So they're talking about using the blockchain to trace back, to have transparency, as you said, to make sure that this came from us. And when the company send a certain medication, there are multiple copies of it. So if you receive somewhere and they compare it, well, this is different, then they can reject it. They say, no, this we're not going to deal with that. This is not something, this is not acceptable.
That's fantastic. So we spoke about identity as one important element or value. The other is the whole traceability.
Correct.
Is there more with blockchain and IoT? Am I missing anything else?
Well, it is you need security. I think a blockchain. This is the first thing I tell anybody who's asking me that question. And you can evolve from security to what does it mean when you have security? What does that mean? Now, in my interviews with some of the local TV stations here, the first question with them, okay, just can you summarize what's going on here? I told them, listen, there is actually a term that's used for this, and that term, it's simple to remember, which is STIP. That's what I call it, which is security, safety, transparency, and privacy. So if you think about
transparency is the other thing, because by having traceability, you're
Correct.
actually tracking every step of the way.
Yes.
That means everybody in the supply chain can see
Correct.
every
Correct.
step of the way. So
Correct.
now we could know where a particular produce was made.
Mhm.
And if I want it like, California grown, and we buy from local farms.
That's
then
correct.
I'm not just trusting somebody who puts a sticker saying that, but now I know where it came from, Gilroy, or where it came
Yes.
from specifically in California.
That is correct. So the four letters here, SSTP, which is this security, safety, transparency, and the other one, which is privacy. The blockchain deals with all of them. To be secure, if it's secure, and to be then safe, because the source, you have a vision. The nodes can see the transactions. They're not going to see, they're going to see that this transaction coming from a certain part with a certain value. Well, I sent $10,000, and then somebody else said, no, I received only $5,000. There is a copies that you receive $10,000. The same thing with transparency, which is open for everybody, can see it in that network. And then you're talking about privacy. The privacy, which means my privacy will be protected because nobody can steal my identity. Nobody can claim that this is who I am and do all these damages here. And yesterday we talked about the big problem with Marriott hotels and
Data
how
breach.
Yes, data breach.
And I'm a loyal customer. I love my
500 million guests, and the scary part of it is when you go outside the United States, they ask for the passport as a verification, and they enter the passport number there. And for me, I'm a simple person here. The passport number, that is not a big deal. But you think about the high-level people who spend time in those hotels, head of states, president, princes, kings, all of them, their information is there. And somebody can access that information. You can think about the implications of information like this, especially it was, since 2014. So we're talking about 4 years of information. They know the track of that person, where he or she goes, where he stayed.
So now when the data breach happened, if they had blockchain,
yes,
then it would not have happened. So
Correct.
Let us talk about cybersecurity, because we are coming back to security in various angles. So before I go into cybersecurity and blockchain, you have actually studied cybersecurity, right? I mean, tell us, what did you study and what's your interest and background in cybersecurity?
I studied cybersecurity at Harvard. So and the person who was teaching that program used to be they call him the cybersecurity czar of the Obama administration. The reason for me to go, and look at it deeply from, a school like Harvard is multiple things. Number one is that the implications of cybersecurity on an election, like what happened in 2016, and also on the government level, on the user level, how that's going to ruin your life if you lost that, and how can we protect ourselves against that. While I'm talking about cybersecurity, the blockchain is really suffering from that. Why? Because when we talk about Bitcoin, there are the dark side of the Bitcoin, and I'll give you an example of this. There are 2 cities this year suffered from from something called ransomware, and one of them is Atlanta, the other one is Baltimore. And long story short, they encrypted their information. You have to pay us before we can give you the encryption. We can decrypt that information. They have to pay, and they said, the group said, you must pay us in Bitcoin. This is the problem, because if it was like a bag of $10,000, you leave it next to a mailbox, people can trace that one. But now it's a Bitcoin, and a Bitcoin, they send it to you. You can do something about it outside the United States. But this is one of the problems that we are trying to solve with the blockchain, which is the criminal use of the technology to satisfy certain things. And you know, a lot of startup is looking at this, and hopefully they can come up with something that will help in that field.
So I was talking about cybersecurity. I actually did a session for a group of lawyers explaining various different forms of cybersecurity risks and hacks, social
Correct.
engineering and spyware and
Right.
everything, right? And I saw there was this ransomware in a group of hotels in Europe.
Right.
So they log in, hack somehow, and then they basically say your guests cannot get out of their house or of their rooms, or they cannot get in. Now you need to pay us. So business is disrupted, their brands are affected. Say they quietly pay. Many of them pay, but the way they come in, other than just some kind of malware, is they come with spyware, which is basically they come in with some software and then it sits and listens for a long time.
Correct.
And then it could do a data breach, or it could do ransom, it could do something else, right? So it could even go away quietly, right, if once it's gathered the information to be used later.
Right.
But you were talking about how blockchain will stop once, even if there is a breach and somebody comes in.
Right.
Blockchain can still mitigate the damage. It can basically limit the damage.
Correct.
So and tell us how that works with blockchain. If Marriott had blockchain, what would be done?
Okay, I'll give you an example, and we're talking about hotels, and then I can pivot to the story of Marriott and how they deal with that one. There was a hotel in Las Vegas, and that hotel was hacked through a fish tank.
Yep.
You heard about
IoT fish tank. Yeah.
Exactly. They have access to that fish tank, and because it's connected to the Wi-Fi, it's connected because they want to change the colors and change all this. The big fish tanks that in the lobby when you go to the reception area, you see it. That's an access point for the hackers. And cybersecurity, first line of defense is artificial intelligence. And artificial intelligence is just not the programming, it's actually the design of a fish tank like this. The same thing happened with the Target, famous breach of data we have it, which is cost them billions of dollars. Why? Because somebody at the top decided to merge the heating and the cooling system with the networking system. The networking system protected the heating, which is basically simple functions. They access through that. So intelligence on both level, on the programming, on the analysis, at the same time on the human when they are doing this design. Now, and I believe in this very strongly, if you're smart, there is somebody else smarter than you, and that person will breach your system and getting into your computer systems or your network. Now here comes the blockchain. And you mentioned something about spyware, you mentioned about all these things. Now, if there is some unusual movement requesting information from somebody unauthorized or not normal, then the blockchain has to verify that request. And if this request is not part of what they're supposed to get, or this request is too much with a certain, the certain conditions, then they can stop it. They say, okay, this node, just isolate that computer. So this is where you see the blockchain as the second line of defense for the cybersecurity. Both of them can help. This exactly like what happened with the IoT. You have the AI, you have the blockchain. You can use the same thing with cybersecurity.
That's fantastic. So it provides, for IoT, it provides complete transparency, traceability, identity,
right,
and also security, not just like blanket security. Even if somebody has come into your network, it can stop it, because at every step, every node is intelligent. So
correct.
It goes back to the original point of peerless, and every node can validate and check. That's beautiful.
That's good.
So where does this go? I mean, what does the future of blockchain look like?
Okay, it's bright. That's what I believe, personally, that it's really bright. But I will have some kind of cautions about it. Blockchain, still facing some problems. And they are I should not use the word problems, challenges, because challenges you can overcome. Number one is the scalability for blockchain, because that is a big thing for the big enterprises. You know, you're talking about IBM, you're talking about, you know, Microsoft, Google, and all of them, they're looking for this. Even Facebook, they have their own department now with blockchain. They're trying to explore that, even if it's against their own business plan, which is you know, centralized. So this is number one. Number two is you're talking about the processing time. The processing time for on a platform is between 2 minutes to 10 minutes on the known platforms. That's not acceptable when we talk about credit card processing, when we're talking about request on the web. All of these things has to be in seconds, or, you know, has to be in sometimes in milliseconds to process that. We have to solve the processing time, and startups are working in this one. I know a few of them that really going after that problem. And then the processing power, because we're talking about mining, which is solving certain problems, proof of work, you know, for you, which is a concept in blockchain, that to make sure that not just everybody go there and access it without any kind of a, you know, check and reward for them for helping with the network. So, and it's consuming a lot of power. And there are a lot of complaint about it, you know, that this is taking too much power to process, you know, a certain, or mine, which is another way of encrypting or processing the information. So if we can overcome the top three problems we have, then the blockchain will go to the next territory, which is now it is ready for action. We can get rid of the criminal image we have, which I described, you know, a few minutes ago. The regulation will be there, because now everybody understand that this is scalable, this is fast, and this is actually, you know, friendly for the environment. It's not consuming this. And this, what we see now is like the internet in the, you know, in the old days when it started. It's like the wild west for us. Everybody there is trying their best to come up with the best platform. And probably by, you know, 10 years from now, we're not going to talk about blockchain. Why? Because any trend it's become like a mainstream, you don't talk about it. Once you talk about it, it's still, you know, an emergent trend or a buzzword.
In the hype,
Correct.
trying to cross that, that trough of illusion, as they,
Yes.
as they call it. Okay, so before we wrap up, I want to bring your book back and show people what it looks like.
Thank you.
And hope people will benefit from that. And tell us again about your class, because anybody can attend the class if they're local here from Stanford Continuing Studies, and
Right.
it's open to all.
Yes, that's true.
Professional adults, like people who attend my class, I told my students already. So tell me the name of the course and where they can sign up and all the good details.
Oh, absolutely. The name of the class is actually CS03. That's the code for it. And the name of the class is Blockchain Technology and Applications. And you can find that information in continuousstudies.stanford.edu. The registration already started on December 3rd. The time of the class is 7 to 9 p.m. and Mondays. It is on Mondays. And I already have, you know, a lot, you know, student in the class. So I welcome everybody. You don't have to be technical. I will make sure that you're on the same level as the technical people in the class.
That's fantastic. So with that, I'm going to wrap up. Thank you so much. This was so much fun.
Thank you.
Okay.
Bye-bye.